As we were building the fitness app, we built some of the rudiments of Instant, and we realized this needs to exist. Like in the future, there needs to be this kind of tool that you can pick off the shelf that's going to simplify most of the drudgery that is involved in programming, right?
Hello, welcome to DevTools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey everyone, we're really happy to have Stepan on with us. So you are one of the creators of InstantDB, which is a really exciting new technology. We're really happy to dig more into that. But before we do, would you like to tell our listeners a little bit more about yourself?
Sure. Hey guys, my name is Stepan. People call me Stopa. I love to program. I like Lisp. I like writing. And I think Instant was this culmination of this adventure that me and my co-founder were on, that where we tried to just make development easier. So it's a little bit of background on me, maybe some fun facts. I was born in Siberia, and I can speak a little bit of Chinese. So that's me.
Nice. So I feel compelled to ask, so where did that development journey begin? Was it with an app? Like, did you set out to create this InstantDB in the platform, or was it more like a product first?
I think it was kind of this idea that was building within us for a long time. So to give context too, I think for us as developers, we started in the era of Heroku and Firebase itself. So I always really admired for Heroku because it let me build things that I didn't know how to run Linux containers at the time. So it kind of really opened my eyes, right? So we started with this where I think like developer tools that seem like they're simple for kind of like beginners, they can end up really enabling people to build serious things. And then as time went on, two things kind of happened. One, I think if you develop web apps today, you kind of feel, at least I don't know if you guys relate to this, that there's usually the same kinds of problems that you deal with over and over again. Like you get a database, you write endpoints, you make sure the permissions are there, you funnel the data into the front end, you need to use a store, you think about optimistic updates, right? And fundamentally, this thing hasn't changed in a long time, right? And I think the closest thing that really addresses this was Firebase for us, where if you use Firebase, you don't have to write endpoints, you can write queries on the front end, everything's reactive by default, it works offline. And what would happen is sometimes, for example, me and my best friend, we'd work at things like places like Facebook or Airbnb, but sometimes just to move fast, to like show some demo inside Airbnb, for example, we would just spin up a Firebase instance and just show what was possible. So the kind of germ of like it should be easier started there, and then we started building these different startups, and eventually in one of the startups, we did use Firebase, but the big problem was most systems require relations, right? You need to be able to say a post has a comment, and then a comment has a user, and give me all the comments for a user. And doing this in Firebase was just such a schlep. We kept seeing this problem. We even wrote a blog post about it, and then everybody would tell us, why don't you do a business about this? And we said, no. That's not a good idea. We're going to do a fitness app. So eventually, as we were building the fitness app, we built some of the rudiments of Instant, and we realized, this needs to exist. Like in the future, there needs to be this kind of tool that you can pick off the shelf that's going to, simplify most of the drudgery that is involved in programming, right? Where actually there's these really fun parts of programming, but I think the kind of repetitive step of take the data, normalize the data, put it in the store, denormalize the data, like we can make that easier.
Yeah, so this seems like a pretty popular topic these days. Just thinking about like the classic app is kind of this 3-layer architecture where you have your database, your application backend, your front end, and translating between all the three is a lot of work, and it's fraught and non-differentiating. So we've seen a rise of local first frameworks, things that like you just think about your database on the front end or your data store on the front end, you interact with it, and hopefully things are good. So what, I guess, where in this space do you fit? So like, or maybe a better, broader answer for this question is like, how do you describe what InstantDB is to
Yeah.
people, and like how does that fit in the local first space?
Yeah. Maybe one way I can also describe this might be getting a little too abstract, but I do think there's this kind of pattern in architectures, and each architecture tries to solve like a different thing. So I'll maybe explaining this, we can just kind of find where Instant fits too. So I think one way you can look at what's been happening in programming is, in the 80s, we can go even before the 80s, but let's start with the 80s. You got client software, right? Like you have personal computers for the first time. You install things in your personal computer, and you don't really in the 80s. Nobody worried about the network, right? There's a famous story. I think it's apocryphal, but somebody asked Steve Jobs, what did he think about the internet or networking, and he took a floppy disk and threw the floppy disk at the person. Said, "That's your network." All right. But around this time, one thing that's interesting is by the 90s, if you look at software like Microsoft Word or PowerPoint, it's like the pinnacle of like client software. Like it works really well. Google Docs is arguably not better when you start typing than Microsoft Word in 1998. So it has all these big advantages, but slowly it had these disadvantages, which is one, shipping that stuff takes forever. You have to put it in in a box. So you have to have these development cycles. Bugs invariably go through. You can't take the data with you anywhere. So, you're kind of tied to your computer. But then 2000 comes along, the internet, and server-based software just, in terms of productivity, destroys the client, right? Like the data is available everywhere. It's easier to manage. You can ship updates right away. And eventually we get things like Rails, where if you're building an app in Rails, you can go extremely quickly. But the downside of server-based software is that every interaction goes through this middle layer of the server, and no matter how hard you try, it seemed that it wasn't going to be as good as the client-side software. But what ends up happening is Chrome just gets better and better and better, to the point where you can run like 3D animations inside your browser. And suddenly now it's like no longer, the network has gotten a lot better and the browser has gotten a lot better. So you can build a different kind of app. And this app has to work in both places. Like when you see something like Figma, what you realize is it works like a client-side app, but it's also on the network. Everything's collaborative by default. It works offline. Like there's these effects to it that kind of change the style of app. But what ends up happening is when you build an app like that, there's just no fundamental tools for this. So it's extremely difficult to build apps like this. So now to kind of go back all the way to the question that you asked, I think there's different ways that people try to solve this problem. One way is, the Rails approach, where we still stay strong and say, no, like everything should happen on the server. But the problem is this ignores the reality that your browser is really powerful and your machines are extremely good. Then there's kind of this opposite approach where it's extreme, I would say, local first in the original Martin Kleppmann definition of it, where it's extremely privacy centered. It's no central source of truth, right? And that can be very good for things like secure messaging systems and things like that. But the problem with that is you are starting to get rid of the benefits of the centralized network, where suddenly like those apps, they cannot do things like they're great for like a single player approach, your own note-taking app. But as soon as you start creating like a multiplayer note-taking app, things start getting very difficult in that approach. So where Instant kind of goes in is a little bit in the middle, where we try to be as pragmatic as possible. Like what we care about is that users can build apps extremely quickly. We want to make it so that within Instant is the fastest way to build an app. But then we want to add the kind of affordances that Firebase had that makes building those apps really fun, right? Like when you build something on Firebase, the app itself is generally better because it is reactive. It does work faster. Optimistic updates come out of view for the box. So I would say kind of Instant is this middle ground where what we're trying to do is to make it really easy to build linear Notion in Figma. And what that kind of involves is some parts local first, where we want to make sure that optimistic updates happen for you. We want to make sure that it does continue working offline, but you want to have some centrality so that you can have, shared cursor state. You can solve problems like what happens when many people edit the same thing. How do you kind of reconcile all of that stuff? And that's kind of where we are. I would say another way to say is we're like Firebase, but with relations. Another way to say is we're somewhere middle in this spectrum that I described, but hopefully that gives the context.
Yeah, this is an interesting space. Like you said, you started in the Firebase era. I started in the Meteor.js era. So like all of these new frameworks very much feel like the promise that Meteor.js had. But I think the main difference is with Meteor.js, it was still all backend and just like syncing to the client. There was no concept of that like local first database type thing.
Meteor is really interesting, by the way, because I think Meteor really did, in a way, inspire Firebase, but it also inspired Luna in Asana, which is this kind of like a lesser known, but one of the first players or first frameworks that kind of tried to solve problems in this way. And then Luna was further kind of adopted by Figma, and Figma built a system that looks a lot like that. So a lot of systems literally just originate from Meteor, and we're still trying to deliver on that promise.
This episode is brought to you by WorkOS. WorkOS is the modern identity platform that makes it easy to add enterprise features to your app without all the complexity. So whether it's single sign-on, directory sync, audit logs, or fine-grained auth, WorkOS handles all the hard parts so your team doesn't have to. And the best part is that the developer experience is really good. The APIs are clean, the SDKs are available in all major languages, and the documentation is just some of the best I've seen. Seriously, I mean, their examples are really clear, their step-by-step guides, there's deep practical implementation details for basically everything you need. They go beyond the basics with pre-built onboarding flows, real-time webhooks, and tools like Vault for managing sensitive credentials securely. It's modular, so you can start with what you need and plug in more as you grow. If you're getting ready to land enterprise customers, or you just want to be ready when they show up, check out WorkOS at workos.com.
So we've talked about a lot about what it is and kind of how it works, but like, what does it look like when you're using it? Like, what is the API a developer encounters?
As a developer, the API is like this. Instead of using useState, you just switch it and use useQuery. And when you do that, suddenly your data gets persisted. All the queries are reactive. You have a similar. You have an API for auth. You have a special API for storage. You can share cursors. But the main change is instead of writing useState in your React hooks, you write useQuery, and then you get the data from a database.
So speaking of getting data from a database, so it looks like InstantDB, you also have to like design your schema structure. In some ways, this is similar to like Prisma or a bunch of other like data layers that people might have been familiar with. So can you talk a little bit about like the schema design and sort of like what that looks like?
Yeah. So this, there's kind of two things we wanted to do with schema and some kind of other inspirations. So I'll share them. One of the things we wanted to do is we wanted to make it easy. So when you start out, you shouldn't have to define a schema. If you want to, you could, but it should be possible to not define it. I think this kind of goes against the grain sometimes, but I do think it's important because sometimes you really do want to move quickly. And the difference between 1 day and 2 days means that, you have the time to build a project or you don't have the time. So we wanted to make that initial experience really easy. But as your app grows, you need to have relations, you need to have constraints, right? So the way Instant works is you define you can start writing code, you can start saving data, and we'll kind of automatically create tables for you. But once you're ready, you can set up a schema, and under the hood, the schema works kind of like a graph database. And this is kind of esoteric, but it's also interesting. The place where we got this idea was from Facebook, where under the hood, Facebook runs on a graph database. And why is that important? Because most of the time when you're writing front end, the kind of queries you want to write are not the traditional SQL queries. They're actually queries with a lot of joins. So for example, just to load a page like a task manager page, you would get the teams. For the teams, you would get the tasks. For the tasks, you would get the author. For the task, you get the comment. For the comment, you get the author, right? So there's this giant kind of query that you need to write. And sometimes writing that is a lot more idiomatic in a graph structure. So under the hood, Instant runs. So in order to make both of these things work, we need to support relations. We want to make it super easy for you to start building without a very strict schema. We run it on top of a graph database.
So with these like distributed systems, there come a lot of different problems that you have to deal with. And in that, you have to balance two things: the instant optimistic updates where the UI shows to the user instantly what happened, and then eventual consistency of relating that to what actually happened in the back end. So how do you like balance those two, and what is Instant's approach to that?
Yeah, I would say there's a lot of pragmatism here too. When we first started working on this, a lot of the initial thought was we need to solve CRDTs to really like make this work. But turns out the surprise is that most, if you look at how linear works or Notion or Figma, they just use last write wins, which theoretically is a CRDT, but I feel like that stretches the definition a little in terms of difficulty. So the way that we kind of do things is like this. First, there's a pragmatic approach where by default, the way conflict resolution works is at the attribute level. So what that means is if you have, let's say, a Figma layer and you change the font color and somebody else changes the font size, that is not going to conflict. But if both people change the font color, that is going to conflict. Now, the way that it by default works is like this. When a user, let's say, changes the font color, in the front end, we keep two different states. We keep a queue of all of the transactions that the user has made, which the server has not kind of integrated into the query. So we say, this is from the perspective of the user, this is the latest value, right? Then if any change happens, which happened before this transaction, we kind of write it on top of that change. So from the user's perspective, they're always seeing the change that they made. Now, eventually that change will come back through the system, and then it will remove that transaction from the queue, and then they'll get into a basic state again. And for like the majority of cases, this kind of solves the problem. But in cases where you have more issues about consistency, I think this is something that, I think platforms can try to solve this, but really this is a business domain. Like you need to know how you want a conflict to resolve. So there's a lot of talk, like for example, CRDTs can help you resolve conflicts, but in effect, they don't fully, because sometimes, it'll reach to a convergent solution, but it actually is not the convergence that you desire. And you can tweak things so that it converges that way, but oftentimes I think the 80-20 approach that works for linear, Figma, and Notion is make it last write wins for almost everything, right? And then in cases where you care, you can kind of funnel the data through one place and then make a decision on what should happen in that case.
I think a topic that'll tie in nicely to both the question before and this one. Just reading through the site, so Instant is actually built on a triple store. There's this database in the Clojure world called Atomic, which is where I learned about triple stores to begin with, I think. So I'm assuming that that's the basis of the graph database. Could you give like a high level overview of like this data model and kind of how it works and how it might be different than users are used to? And I guess to add on to that, if there's anything about the triple store that enables the sort of sync that you just talked about, that'd be interesting to hear more about too.
For sure. It's a very interesting question. So let's first kind of take a step back. I think the way you can discover the triple store paradigm is like this. Imagine you're trying to build a database and you want to support relations, right? You want to be able to say users can have posts, posts can have comments, and you want that to be fast. Eventually, you'd also like to have strings should be strings and numbers should be numbers, things like that. But that's your kind of constraint. Now, you could try to solve this problem in multiple ways. You could try to solve this problem by basically implementing the entire SQL system, right? But the problem with that is the language of SQL itself is very, very large. And I think if you start out trying to create a database that competes with Postgres, for example, that's going to be a painful thing because 25 years of excellent research goes into it. But now, what a triple store can do is, if you think about the most simple way to express relations, you could say it's just, you could imagine instead of having a bunch of tables, you have one table, and you say for a row, you can explode it out and you say, for example, user ID 1, name Andrew, right? User ID 1, favorite color blue, right? And then to have a relationship, you can say user ID 1, podcast, devtools-fm, and then and suddenly now you have this relationship, right? This model originates from like RDF data stores and all these things where it's a very nice way to explain like facts of information that aggregate together. The nice thing about it, I think, like, why is this so useful, is it allows basically three things for us. One is, I mentioned on the client, you need to run queries locally, right? For it to work offline and to get optimistic updates. Now, if we wanted to run SQL queries locally, we would have to use something like SQLite, which is a very large binary to add into anybody's website. So the benefit of this kind of triple store approach is you can write a query engine on top of that in about 100 lines of JavaScript. Now, it's obviously not going to be efficient, but also you can make it very, very efficient. Like there is literature on this. So the first thing that the triple store helps in is that suddenly now you can write client-side databases in a very, very small amount of code. The second benefit that it does is triples are naturally good at this conflict resolution we talked about. Because, for example, Andrew, favorite color blue, Andrew, hair color black, they're separate rows in the database, so they don't conflict with each other, right? And then there's a final advantage, which is what we wanted to do was we wanted to make it so that you could truly have a free tier. So, a user can sign up an instant. We can spin up a database in theoretically like 5 milliseconds. But when I say spin up a database, all we do is create a logical row in this single database that kind of partitions data. And the benefit of that is now every user can have a truly free database that never pauses. Because we can also write this kind of query engine on top of something like Postgres and get the benefits from there. Did that make sense? I feel like I might have gone very, very broad, so let me know.
I feel like explaining triple stores in audio format is a hard thing to do anyway.
Yeah.
The thing that struck me when I was reading about Datomic for the first time is like they have this document page on like the universal schema where they do lay it out like oh, if you're doing this in any database, you would have like one table. It's like one big table, and here's like the very uniform data type. And I was like, it blew my mind when I first saw it. So you have to like be really good with indexes, I'm sure, to like make this feasible. I think to sort of like build on this, so you've designed your own query language for InstantDB as well, and there's some things that I love about it. It's like written in raw.js. It reminds me a little bit of GraphQL without needing the sort of like special language, which I think is cool that you're able to do that. But something that jumped out to me is that it compiles to Datalog. And for those who aren't familiar, Datalog is like a query language specifically for like triplet like data stores or like these like Datomic uses Datalog. So can you tell us a little bit more, one, about the query language and sort of what your goals for that are? Like two, like why write your own query language? I know we talked a little bit about like SQL and not wanting to run SQLite. So yeah, maybe take those.
Sure thing. Let me kind of form the thoughts. So I think the first thing is maybe why Datalog, and then maybe why something on top of Datalog. Because the first thing that I wanted to kind of mention is the triple database under the hood. This is not something that we necessarily like. We want the user to just feel very productive, and they shouldn't have to worry about the underlying data structures, like kind of similar to Postgres in a way. Like when you add an index to Postgres, you kind of know the data structure underneath, but you don't really know, or, and when you run a query in Postgres, it can do so many amazing things, and you just, it's like having like a mathematician in your team that's doing the exact right thing to write your queries, until it's not, which we can also talk about too. So that the way that we want to make all of this, right? We don't want to kind of. I also believe in this one thing where you need to meet developers where they're at. So there are some things that are important to tell somebody because it's like an expertise thing. Like you need to, if you want to be a great guitarist, like you need to know some like unique thing about the guitar. But for some things, like I don't think you need to know the underlying structure too much on this. So what we wanted to do is we wanted to give people, like when you're writing things in TypeScript, you naturally think about things as objects and relationships between them. Versus if we just went with a pure triple approach, there are no objects. There are these aggregations of objects, which is an elegant idea, but it just contradicts very deeply with TypeScript. So what we wanted to do was, look, let's give people something that is the most convenient way to fetch, to describe what you want. And in my opinion, one of the most convenient ways, it's GraphQL. Like users, posts, boom, right? Writing that query in SQL to get that data structure back is actually, I would say, intermediate SQL, right? The very basic one is a join clause, but if you want to aggregate each post under a user, you have to use JSON, JSON ag. And I think most people don't do stuff like that, right? So I think GraphQL really makes things a lot simpler. But the problem with GraphQL is twofold. One is it does add this extra build step. And I do think that really impedes productivity when you're getting started. And the second thing is, it's really nice when when you can modify, your language, JavaScript, for example, or TypeScript, it's great at modifying data structures. It's not great at modifying strings or things like that. So it's very nice where instead of doing like this compiled like AST node thing, all you're doing is just taking an object and, let's say you want to create a table where you do filters, right? Now you can just construct your query as the user changes buttons, and it's a really delightful experience. So we wanted to give the user this power. Like, it's very frustrating, in my opinion, in most languages. Like, for example, SQL, you cannot do this, right? You cannot, it's usually a string, so you have to kind of think about how you're going to generate this. But we didn't want that. We wanted to make it something, it's a real data structure that you can use functions to generate your query. And then why not, but in order to run that query, how do we run it? All right, well, under the hood, because it is a triple store, one of the most elegant ways to run queries on a triple store is using Datalog. And the reason is Datalog is this much smaller language compared to something like SQL, but it is equivalent. Like you can do almost everything you can do in SQL. You can do, I think theoretically you can do everything. So that's what kind of let us say, okay, under the hood, we have this triple store. We have this language on top of that, which lets us easily query into it. But then we give this layer on top for users, which are pure data structures, which give them the data that they expect, which is objects and the relationships.
So was using Datalog under the hood, was that so that you could leverage existing like query optimizations or like pull some off the shelf like libraries or something in order to not have to re-engineer that versus just like having your query language directly compiled down into, I don't know, something that does the data fetches specifically?
Yeah, the main one was, it's kind of like, I really believe, sometimes, for example, DSLs get a very bad rep in the programming world because you can do them wrong and they can be very painful. But I think if you do them right, they're very, very good. And you can actually see this, that like most of the most useful software are effectively DSLs. So the way that we look at the data log is kind of like this intermediary structure that that's easier to handle. So what that lets us do is, instead of, for example, let's say we wanted to compile directly to SQL, that would create on Postgres this very giant CTE. But and then on the front end, we wouldn't be able to compile to SQL. We'd have to just kind of run those manually on the data store. But the nice thing with this intermediate structure is now on both sides, we can have a lot of focus on generating this intermediate structure. And then running a Datalog engine is, I would say, reasonably simple initially. So if you wanted to, for example, do a hackathon where you write a query engine, guaranteed you can do it in Datalog. Like, I have a blog post. You can read it, and at the end, you'll have a query engine. If you try to do that with something else, like if you want to try and make your own SQLite, I think you'll have a tougher time.
So a through line I'm seeing in kind of like all the stuff you guys put out is making complex topics really simple and easy to consume. Like even on your homepage, you're like, hey, there's fetch. Why don't you just use that? And then you're like, oh, well, there's all these problems you'd have to think about and you don't want to worry about. Another topic that kind of is in that same area is permissions. You guys call that out very explicitly in your docs as something that you wanted to make better over Firebase. So like what were the shortcomings of Firebase and how have you fixed those in your new system?
Yeah, so I would say, like where at least where permissions was inspired for us was another kind of ex-Facebook story. So inside Facebook, there's this library called the Ent framework, and they did a very interesting thing with how permissions work. First, you write permissions in a language that in the same language that you write other things in. Second, the permissions are written at each object. So there is no way for a developer to write a query where they can see something that they're not allowed to see. So every query you can think of takes in an argument called the viewer, right? So it's either a user or a page or something like that. And the reason they did this is, you might think that the simplest way to do this is every endpoint has like an if statement. Can you do this endpoint or not? But the problem is when you get more and more engineers, this just starts to break down. Like, you do not want to have any privacy violations. Given the reputation of Facebook, you would think that we would be willy-nilly doing that. No, we really did not want that. So we worked very hard to make sure that that wasn't the case. And one way you can do that is to push the complexity down to the object level. I think Firebase, honestly, as I go through it, I think maybe I was too mean to Firebase originally. I think they actually did a reasonable job. I think the problem is it just gets tough. You're writing these strings. There's these kind of gotchas about, because it's a document model, it's unclear, if a permission level fails here but passes at a parent, what should happen? And technically what actually happens when the parent passes and you just get all the data. So it's easy to kind of mix up. But what we really wanted to do with Instant was to kind of give you this object level permissions. Turns out Firebase has a great sub-language called Cell, which Google made open source. And we use something similar we use it to generate our permission rules. But I think the big thing, or the big aha is, I think it is really important to put permissions at the table level, basically, because what that allows you to do is you now no longer have to worry what kind of query can be written, right? In 6 months, if I make a new endpoint, like, will I add in a security vulnerability? No, it's impossible, because you can only get data you're allowed to see.
Yeah, it's cool. I like how like consistent it all feels too, and it's nice to have it all sort of built in the same like language, especially because I've definitely worked with like, obviously different query languages, but then different policy languages, and like having to jump through a bunch of like DSLs and different tools, or like maybe they need build steps or they compile or their extra libraries or whatever. All of that stuff can stack up to not only be a maintenance burden, but also like be hard to piece together like how everything fits together. So I think packaging everything up for Instant like this is pretty nice.
Yeah, it definitely took a lot of research. And I would say for permissions, to be fully frank, I think we still have a long way to go to make that really good. But kind of to give a goal, like a start of where we're headed is, when we were doing this research, some of the simplest ways you could solve this problem is to do, for example, role-based security or ACLs. But the problem is eventually you hit these issues where you cannot express what you need to express in these languages. So you kind of duplicate your data model from your database into like an ACL. So we didn't want that to happen. We wanted it to make it so that you can express the relationships about who's able to see what, and it's in a single place, like your database. So that's kind of where we're headed. Right now, I think we still need to add like better, like another thing that I love is like Rails active record. In my opinion, has this really beautiful way of describing how an object looks, validations for an object. Oh, this email has to be past this regex and things like that. So eventually we want to get to something that looks kind of like active record.
So that's pretty cool. I mean, I think active record is a good target because of like how like pretty straightforward it is to implement. So like what is like an authorization setup inside of InstantDB? What does that look like today? Can you just like sort of walk us through like if you're trying to set like up some basic auth flow or permissions or whatever?
So here's how it works. First, when you start off, we make everything permissionless. So you can start hacking, make things work the way you want. Once you're ready to add auth, there's like a quick start. You copy a quick start, you can get magic code emails working right away. You can get signed in with Google. There's an integration with Clerk. So now you have authentication. Once you have authentication, right, well, now you can write permissions based on this authentication. You can also write it without having authentication, but I'm kind of walking you through this steps that you would normally go through. And then there's a kind of like a mini language where you can write special rules on each object. So you could say, okay, I want to make sure that a post can only be edited by the owner. So you could say a rule like auth.id is equal to post.owner. And then boom, no matter what kind of transaction comes into the system, we're going to guarantee that invariant for you. That's the outline. There's some like cool things you can do, like sometimes you don't want to have auth, right? So we have a system where you can pass in secret context from the front end, so that then you can have something like, if you know the secret password, you can see that data, things like that.
Like a password protected like chat room or something.
Exactly.
Nice. Cool.
So one problem with these applications that do lots of syncing of data onto your local device from a server is what to sync. When we talk to the founders of Linear, like if you're loading up a Linear instance of your team's issues, that could be a whole boatload of data. So how do you decide like what to sync, and like how does like the syncing layer happen for you guys?
Yeah. So this is kind of also where things like local first start to diverge, right? Because if you're doing fully local first, you need to sync the entire database, but or something that approximates that. But the problem is you can't have like Twitter doing that. So we took this inspiration from Asana Luna via like LiveGraph. And the way it works is we only sync the data that you query. So the way it works is the front end sends a bunch of queries to the server, right? We then respond to those queries, and we cache all the active queries, but also then inactive queries are still cached as well up to some limit. And then what happens is we just send you the slice that your data cares about. And the way that kind of reactive architecture works is you can think about, you write these queries, and these queries have kind of like what Asana calls a topic. And a topic describes what part of the index this query cares about. So for example, let's say you're getting posts where owner is blah, blah, blah. You might say, give me I'm going to make this up a little bit, but on the posts table from this range to this range, that's what we care about. And then when a transaction happens, we tail the write-ahead log from Postgres, and we can generate topics from that as well. So it could say, this invalidates the post table from this range to this range, right? And based on that, we can do a match, invalidate the query, and then send an update to the client.
That's pretty smart. Tellogs are superpower. Seems like a lot of like syncing engines are using those. That's pretty clever. I guess a question to add on top of that though. So you mentioned earlier like presence, and I've seen it like talked about in the docs too. So it's like if you were wanting to build a Figma style experience where you have like two cursors that are showing on the window,
Yeah.
you don't actually want to save those cursor positions to the database all the time. So it's like I assume that you have to handle this sort of specially. How do you do the real time sort of?
Great question.
Yeah.
Yeah. So we have like a separate kind of flow for that, because when you think about the problems of presence, it's actually in some ways it's a lot simpler, right? Because there are no relations in presence. You can't say like, give me only the presence for this chat room or blah blah blah. It's just an object, so it's a lot easier to invalidate the right pieces. And sometimes you actually don't even invalidate, really. You just send the new information that the user cares about. And the main thing you have to do is to keep all of that in memory. So what we did was we created kind of like an offering on top of Instant. So, and what that does is all presence information is just in-memory data. So you can just think of it like an in-memory map as the very basic system. Now, how do you make that work when there are multiple machines? This is where things like closure, and we're happy to talk about that too, come into use. So, there's these great solutions already. There's a library called Hazelcast, which makes it so you can share data structures across machines. So we have a Hazelcast instance in our main machine that kind of keeps track of all the presences. So you join a room, you have your own presence, you can send messages, and this kind of circumvents all the database invalidation logic, because again, for this, you really don't want any latency at all. Like you want to like get this as simple as possible, like as quick from point A to point B. So what we do is just do basically everything in memory when it comes to presence.
That's pretty awesome.
Oh. Yeah.
So look. Oh, go ahead.
Oh no, I'm just I like the awesome. I give you guys a. It was hard. So,
It sounds hard. I mean, I think all of the stuff that you're doing is actually kind of hard. So, I mean, props for doing it.
Speaking of hard things, you guys probably have some nice hard things planned for the future. What are you guys working on right now?
Well, I feel like there's, oh man, like one, it is interesting to run a startup in that there's like phases of a startup. In the very initial phase, it was just kind of research, and it doesn't feel like a startup because you don't have any customers. So it almost feels like unemployment with a lot of fun technical research. But once you have customers, then things get very serious, and you really need to make sure that customers are happy. So I think there's kind of a few things that we're working towards now. One, we need to hire. So if anybody's on this, listening to this, wants to hack with us in San Francisco, we would be very excited to have team members join, because at this point we you can imagine we have this kind of giant system, and what we need to do is we need to make every single part of that system as good as possible, so that eventually, right, like I think already you can start building like almost any app on Instant, it will work. But once it gets even more and more and more, like we want to be able to support enterprises. We want to be able to so for example, support iOS and Android. Right now, we only support React Native. That we have a TypeScript library, so you get automatic types. But I think, if you look at things like archetype, that's an example where I just recently saw where I'm like, wow, these guys do some crazy things. Like if we could do things like that in our client-side SDK, our users would be so happy. All right. So there's just a lot of work to do. I think the main things are service our users, make them as happy as possible. Any place that they're feeling Instant is lacking, we want to just make the quality bar better and better and better. I really always admired Linear's statement that they have a 0 bug policy. So I think we want to get there. We have some bugs, but every time we're trying to solve them. So that's the kind of like state we're in. We need to hire is the main energy. So if you guys are if anybody watching this is interested, please reach out.
Yeah, getting those TypeScript types to be like perfect for your use case is no small task.
Definitely, Andrew. Definitely.
Yeah, you got a lot of different areas of type. Just the query language alone is going to be a fun one.
Oh yeah. I'm thankful for I think his username is Catz on Stack Overflow. I just every time there's an issue, I'm just go on Stack Overflow. There's like a TypeScript wizard who takes this time to help. So things like
Nice.
that. But yeah, having 3 or 4 more members, I think we'd be very excited to kind of currently we get kind of larger companies talking to us, but we really want to make sure that we can actually like service them with a dedicated support and things like that. So I think if we had a bigger team, all users would be happier. So
yeah, the archetype guy does do contracting. So if you want if you want a great TypeScript experience, you could probably pay him some money to do that.
Oh heck yeah.
So with where you're at, what are sort of the ideal use cases? So if people are kind of looking for infrastructure similar to what you're building, like who are the kinds of customers, like what are their shape that you really, really want right now?
Yeah. I think right now we have 3 kinds of kind of happy customers. So one of them are literally trying to build like Notion, Linear, or Figma. So if you're trying to build these things, I think Instant will really like help you build that faster. And we are still a startup, so I'm not saying that we're gonna, if Figma came to us today, I would say, okay, wait 6 months. But if you're a startup and you're willing to take the risk with us, like I think you can get a really big edge doing that. Another side is people who really like to prototype fast. So we have a lot of people who, for example, they're building a startup and they pivoted and they need to like pivot and try a bunch of different ideas. I think right now, Instant is probably like one of the fastest ways that you could pivot or like build a product from scratch. So I think those are the kind of, young startups under like 10 employees who are willing to take a little bit of risk, but want to, be very productive. I think would be very happy customers of Instant.
Nice, cool. Andrew, you want to do the future one?
Yeah, sure. So we always like to ask a future-facing question to finish out the episode. So what do you think the landscape of front-end first technology will be like? Is that going to be the standard for what people expect of software? Or do you see the ball going somewhere else?
Great question. I do think there's that original kind of statement I started with 45 minutes ago, in that I really think there's this architectural movement, and we were client only because there was no network. Then we were network because there was no client on the browser. And now there's both. And this is like a fundamental shift in the way that the materials you have are now different. So you cannot build the same way that you built before. And I really believe that in order to build the next kind of, like almost every app in the future is going to feel like a Notion, Linear, or Figma. They're going to work everywhere. They'll work on your phone, they'll work on the tablet, they'll work on a laptop, on somebody else's laptop, but they're going to feel unbelievably high fidelity, and they're going to feel very fast. But in order to do that, I think there needs to be this infrastructure. So that's where I really think things are headed, and we could talk about AI too, but I'll focus on the dev tools. Let's go.
Yeah, I do think that like we've had this back and forth, but like as you were talking about earlier, when in the 80s or whenever, when it was just like pretty much just client first, is like the capabilities for doing internet connected devices and rich multiplayer experiences, just like the infrastructure wasn't there. And then when it was there, we really overcorrected to it. And then I think in the early like 2010s too, there were like a lot of people exploring just like, oh, we're just going to build a spa or whatever, single page app. and then, you know, is the overcorrection again, like, no, just server side. And I don't know. I feel like it's going to balance
no,
out
just local.
somewhere.
No, just
Yeah.
yeah.
I do feel like it's sort of, it feels like it's teetering more to the center now, where like we're coming to realize that we need both. Like we need to be able to interact with our software without the server always having to dictate everything most of the time. And of course there are like places for technologies like Elixir's Live View, for example, that does everything on the server, but gives you this real-time experience. That's great for certain situations. But I think things like Instant need to exist for like a lot of other use cases, because it's like there's more pressure to build apps faster. I think you're sort of hinting towards AI. It's like also I think there is something to be said about like a smaller API surface area to do more things. Even though abstraction costs can be kind of high, it's like we have more appetite for that, I think.
Definitely. And I think you bring a good point about the SPA as well, because I think the one mistake we had during this kind of SPA era is we were more okay with like a lower developer productivity. And then the other mistake is being okay with very high developer productivity, but not software quality. So I think eventually it needs to be both. And I think it is possible. So that's kind of, I hope in the future our children are building like very beautiful apps at 1/100th of the effort. So
hopefully we'll get there. But that wraps it up for our questions this week. Thanks for coming on. This was a really fun episode. Once again, treading the local first waters and seeing how you guys are doing it. So thanks for coming on and talking about it.
Cheers. This is a blast, guys.
Yeah, thanks for coming on. Instant is awesome. I'm really excited to see what y'all do with it. And yeah, good luck.